Okay, I hope the screen is shared to you. I think you can see the screen also. Okay, now coming to the second class of this economic analysis of solar energy. Last class, as an introductory part, we discussed the theory part behind the solar economics, how it is important to decide with respect to conventional solar energy systems. Also, we have discussed some advantages of these renewable energy sources, especially the solar energy sources. Today, we'll see the different equations of the method of finding the advantage over the economical viability of this solar energy systems. So both thermal as well as PV system, solar energy systems, we are going to discuss in examples. The main focus of this unit will be not finding any efficiency or the performance of any solar system or the temperature values of the solar systems. Here in the subject, the main focus is to find out whether the system is viable or not, or to find out what is the payback period or the life cycle cost, cumulative savings, or the benefit of the system over the given length of time. Okay, so today we'll go with the next discussion, that is on coming to this graphical representation of all the savings and the spendings or the benefits from the solar systems. So for briefly to explain all these definitions, what we discussed in the last class, so this graph will help us to discuss in more understandable way. So this will make it full screen. Yeah, I'll take highlighter also. Okay. Yeah, coming to this part, in the graph we have three main curves. Okay, one curve is starting from zero. So before that, I can say you on the x-axis we are going to take the life or the number of years from 0 to n number of years, how the solar system is going to work. And on the y-axis, you can see the money spent on the solar system or money earned as a benefit from the solar system, maybe in dollars, euros, or rupees. So many examples will be there. We'll consider this as in rupees as per our convenience. And you can see above zero, whatever is there, it is a profit like or the money in hand. And whatever the negative sign is there, so that benefit over the time we are going to get it. Okay, so that negative signage shows the spending by the person. Now coming to the different curves here, as I told, there are three main curves. The first curve, what is starting from the zero, okay, as you can see here, this is what the spending, what you are doing with respect to the conventional fuel systems. So that saving, say for example, for a same solar system, earlier we were dependent on the grid system or the electricity supplied by the government, maybe through coal plant or any power plant which is running on the conventional energy sources, or a system which is dependent on diesel generators or the petrol generators. So where such fuel cost, whatever is incurred in the conventional systems, are overcome here in the solar energy systems. One we switch over to conventional to non-conventional energy source or non-renewable energy source to the solar type renewable energy source system. So here in this concept, we are going to call them as savings because we are not spending anything on the conventional fuels or as such, say for example, maintenance or the regular investment to run the system. So that we are going to call it as fuel savings. And over the period, if you see this curve, okay, so this curve is keep on increasing or adding the all savings or the annual savings. So once you take the sum of monthly savings or the annual savings, so that savings, total savings, we are going to call it as cumulative. So as it is taken cumulative, the addition of all the money is going to be summed up at this point, and we are going to call it as cumulative saving curve. Okay, and at that point, a B line is drawn here on the x-axis over the time. Later we'll discuss that what is ABCDE, what it indicates. So I hope this curve is clear. So once you switch over a solar system without any auxiliary conventional system, then we are taking that whatever the savings on the fuel, what we have done. So that saving on the fuel or the conventional fuel, after summing up, we are calling it as cumulative fuel saving curve. So that curve indicates the cumulative saving on the fuel. So no fuel or extra fuel is required for running this solar system. So that amount is saved. So that's the benefit. You can see here plus sign. So that is one of the benefit from the solar energy system. Next curve we can see a curve starting from the down payment, and it is coming and ending up to here on the x-axis. So say for example, any system if you set up, if it is a high cost system, initially we take a loan or you can say the mortgage. Okay, by keeping one property or keeping some surety, we are taking some loan. And for a given solar system or any given device or you can say system, or even in case of vehicles also you might have remembered, first you have to pay some down payment, then you have to pay some EMIs for any device if you want to purchase or like a vehicle. Similarly for a solar system also, if the initial cost is very high, no doubt, compared to conventional system, solar energy systems are having uh, initial high cost. So that to bear the initial high cost, the person will take the loan. Okay, and because of the loan, what the vendor or a person in the solar system supplier, he may give the system for a given down payment. And after this down payment, you can see the initial investment, total huge investment is reduced to some value. Okay, so that small value you have to pay initially, then remaining amount in terms of EMIs, some interest rate you have to pay. So over the period, what will happen? Whatever the total loan amount is taken, it will go on decreasing. EMI rate may be fixed, and percentage of the loan taken for the EMI that may be fixed, but the amount remaining with respect to bank or with respect to supplier, so that EMI value or the value of the money you see as you go on giving to the customer, one day what will happen? The total amount whatever is taken from the supplier or the bank, okay, or who is providing the surety or the benefit of loan, so one day it is going to close. So that curve indicates the mortgage balance or the loan balance or the loan curve. You can say loan curve directly. This is the loan curve. So that loan curve initially it will be very high because you have taken a lot of money. Once you go on paying month by month or year by year, it will go on decreasing. So one day it will be closing. Okay. Next curve, the third curve, what I was telling is this one. This is the cumulative savings. Okay, or what the benefit you are getting from the solar system. So say for example, today I will set up one solar PV system at my home or your home. Initially for the 0th year, everything is spent on the system. We don't have any profit or we don't have any positive money in the hand. And this loan money, whatever is there, as I'm showing here positive, but it is not in hand. Okay, the banker or a loan provider, he is going to provide this money and it is completely used in the giving for the solar system itself. But whatever the money it is shown in the bottom curve, you can see here, this curve, bottom curve, this is the curve. What it indicates is every year, whatever the benefit, whatever the profit we are making from the PV system, a solar thermal power plant, or solar based any thermal storage device, so whatever the solar system is there, from that, whatever the outside benefit you are getting, so that is indicated by this cumulative saving curve, the bottom, or the profit from the solar system. So once you spend a lot of money in setting up the plant, later what happens is it takes some year, it takes some 2-3 years, such that the value of the money will become positive. So at what time the value of our money becomes positive, that is shown as A here. Say for example, after 2 years or 3 years, okay, whatever the profit is coming from the solar energy and monthly or yearly, whatever we are spending on the solar system, by saving this fuel cost as well as by loan amount, whatever you are paying. Okay, the balance, if you see, once it becomes positive, then you can call it as the time needed. So A indicates here the time needed for the yearly cash flow to become positive. That's one point. So net value, if you take, it is positive. But total profit only should become positive, means it should travel some time. Then this B point you can see here. The B point is nothing but this is the time required for the cumulative fuel savings to equal the total investment of the solar system. For example, say I'll be using a petrol or a conventional fuel vehicle for a number of years. Okay, say for example, B is having on 5th year. So 5 years, if I use any conventional fuel vehicle, I am going to spend a lot of money on the fuel maintenance, etc., etc., etc. But after switching over to a solar car, okay, as you assume one solar car I'm using, then what will happen? After 5 years, whatever the fuel cost was there, okay, if that fuel cost saving, what you are doing by a solar car, okay, if that is equal to the total or the total investment on the new solar system, if that is equal, then what I can say is that is the point, or that is the time needed to make it equal. If the fuel savings are equal to the spending on the solar system, then what I can say is all the fuel saving is done on the spending of the buying of new solar system. Then afterwards, after this point B, if you see whatever the benefits you are making, everything is in positive. This cumulative savings will be in the positive region. All the benefits will be taken by the person. And after the cumulative savings on the fuel, if you see, there is no much spending on the system. Only spending is what? Maintenance and other things. There is no fuel cost incurred, or there is no much investment required in the future for these solar systems. Same thing applies to the conventional and non-conventional energy systems like vehicles. Okay, or else the common way to calculate this payback period, payback in the sense, say for example, I will buy one vehicle and I'll spend the one vehicle for maintenance and fuel for say for example 5 years. So that total cost, if you compare with a solar energy system, if that is going to save the money which is equal to the initial investment of the solar system itself, because the solar system uh, uh, pricing will be higher than the vehicle pricing if you assume. So that is total care is taken by this fuel cost adding. Okay, so that you can call it as payback period. So when I'm going to get this invested money, okay, then after that getting the money which is equal to the investment, okay, after that year I can tell it as a profit to me. So until that time we are going to call it as payback time or payback period. So this is without discounting on the fuel savings. So discounting depends on the time, or even the money value is also we are calculating for a given year. That is a present one. That also we are calculating. So that will come to the later stage. Now C point you can see this cumulative savings or the benefit from the solar system is touching this zero line. This indicates the time needed for the cumulative savings to reach zero or to make it positive, from minus to positive, or when it reaches zero as a balance sheet. That point we are calling it as C point. Then you can see after C, here some small DP is shown, or you can see the down payment, which is equal to the down payment. See what are the down payment, what you have spent initially. Okay, so D indicates what D indicates, it's the time needed or time taken for the cumulative savings to become equal to the down payment on the solar energy system. So at this D, say for example 7 years. After 7 years, I may tell that the solar energy benefits are positive, then it is giving some payback after the fuel savings, and it is becoming positive after C. And after this D point, I can tell that it has also given me the benefit of down payment of from my side or the loan payer side. Is that clear? Now E point. So at this E point, you can see both the mortgage balance of the loan balance curve and cumulative savings of the solar system. Both are crossing each other. This is very important. So this time needed for the this is the time needed for the cumulative solar saving to equal the remaining debt or the remaining amount on the loan. Is that clear? Now after this you can see whatever the loan you are paying, that is also taken, or the benefit is available from the solar system itself. Means after this E point, you can take the benefit of the solar system itself, and the same amount can be paid to the loan itself, not from the pocket. This is all benefits which are available or possible from the conventional systems. Okay, so by these also you can explain the cumulative savings or cumulative spendings, annual savings, okay, different definitions, and also the life cycle costing. So after these NN or NE, you can see the undiscounted life cycle savings. So after the life, say for example, after 12 years, the life of the system is going to complete or the efficiency is going to reduce. At this point, I can say, without any discounting on the fuel or without any discount on the system itself, after 12 years, this is the life cycle savings, what it has achieved at this point. Okay, so from this you can analyze life cycle savings, cumulative savings, annual savings, everything by the curve itself. So that explains all the definitions in the chapter. Next we'll discuss the remaining part, that is just a minute. Here you can see. In this we are going to discuss what is the meaning of discount rates, net present value. So that is nothing but the present work. Of the value, then return on investment, then payback period. Or else, in place of going with the solar system, if the discount is possible on the fuel itself, so the petrol or diesel, what we talk, on the conventional system itself, we have a discount. Then whether it is going better for dependent on the conventional system or the non-conventional system for a given period of time. So that all depends on the discount rate, what is provided on the conventional system or else on non-conventional system. That comparison we can. Then one more is the net present value. So here what we are going to do is the cumulative savings or the life cycle savings, whatever is done, it is done for a given number of years, taking into consideration the present value of the system, present value of the loan. Okay, but it is also in a given situation, these values will decrease. Okay, as the market discount rate increases, the market discount, if it is giving more discounts, what will happen? The value of the system in the future it is going to reduce because of the more discounts. And also the discount rate for which the values of cumulative savings or life cycle savings is zero. So that is called as rate of return. The meaning is, see here, the cumulative saving curve and the life cycle savings. You see both the points. If both the points are zero, or if you take the difference of these two, if difference of these two are zero, then I can say that the rate of return is achieved. Okay, and another term is here, that is a payback period. So it can be defined in two ways. One is time needed for cumulative savings on the fuel or electricity on conventional system. If you compare, or the income from power fed to the grid, if you compare these two, conventional and non-conventional energy profit, if you compare, so these two values, if they become equal to zero to the initial investment on the solar system, then we can say that the payback period for a given length of time is achieved. Or else we can define it like this: the time needed for cumulative savings to become zero, and the time needed for annual savings to become zero. So the profit is a positive line, but until what time it is taking, until what time the payback of the initial investment is possible from the all cumulative savings. So if the profit of the solar system is same as the initial investment of the complete system. If you take that point of time, you can tell it as a payback period. So next, you can see the life cycle costing, how we are going to calculate. So this is all common method in engineering economics, savings. All these can be found out after its life cycle. So that value we are calling it as life cycle costing. You can see that the method involves three essential components: capital cost spent, equipment maintenance cost, and savings. Savings is nothing but either it is saving on the fuel cost or the profit from the solar system. So all these costs, if you take and analyze, then I can tell it as a life cycle costing. So the sum of capital and maintenance cost is compared to the present worth saving estimated to occur from the investment over the life of the equipment. So this we always have to find out for the life of the equipment, and later we can say whether it is a earning or a loss or a profit or a loss. Now the next important factor is for the numericals. That is the present worth factor. So here you can see for a given series of annual fuel payments. Okay. Now we'll compare with one conventional system. So say for example one conventional system is there or like vehicle is there. Every year I have to spend some fuel. And every year for the fuel, it is not a fixed cost. It is always increasing, yes or no? So same example you can compare with the conventional power system. So assuming the payment at the end of the first year is say for example 1 rupee. So what they have done? Initially they have taken 0, this point. Initially they have taken at 0, there is no fuel requirement. But for 1 year, what payment they are doing? As an example, they are paying for as a 1 rupees. Then with increasing fuel price, or you can say inflation on the fuel. So it is increasing by I%, because here we don't know what is the percentage of the fuel, what it is increasing. So that you can assume it as 1 plus I. So every year this I% of fuel inflation rate is going to increase. Similarly for third year, if you take, I can write it as 1 plus I square. Okay. And similarly for the fifth year, sixth year, like that. Nth year, what I can do is, as for third year, you can see the fuel price, what we are going to spend is 1 plus I raised to square, depending upon the inflation rate. Similarly, for the nth year, if you see, what I'm doing, 1 plus I raised to n minus 1. So similarly, as second year, you can see 1 plus I raised to 1 for second year. So for nth year, it is 1 plus I raised to n minus 1. So these all values we are going to sum up. Okay. And one more example I told. If the discounting is given, the money spent on the fuel would have been invested to earn more income. So to explain this, what they have done is, they have told that same money what you are spending on the fuel, you can keep that money as a fixed deposit or a bond, and you can get some benefits with some more interest or with the same interest. And that money also you can spend on the fuel every year. Or else what you can do is, same fuel price you can spend making one agreement between the fuel supplier and the customer, so that he can provide some discount and you can pay the money according to the discount provided. Or else you find out the total money required for 5 years, keep the 5 years total money in one FD or whatever bond. According to that benefits, you can go on paying the money. So assuming that period for n years for fuel payments, and rupee 1, see here, rupee 1 payment for first year is paid, and with discounting, if you want to consider, I can take the discounting factor as 1 plus b raised to n minus 1 for the first year. Similarly for the second year, as similar here without discounting I have shown 1 plus I raised to 1. With discounting means it will be 1 plus I into bracket 1 plus d raised to n minus 2. So that discounting amount, if it is a benefit it will be added with this. If it is a loss, again you can consider it as in the other way. So that we'll discuss in the problems, you understand. In the third area, you can say 1 plus I square as written earlier, then 1 plus d raised to n minus 3. So similarly, you can write for nth year, or you can go on adding these all values and you can find out the sum of. So that sum of the n years discount with inflation rate on the fuels used, or whatever the profit you are getting with inflation and discount rate on the solar system also. Okay, at present, what is the value of this sum for the given n number of years? That sum of value will tell us the present worth factor. So we are getting one factor and you have to multiply with the initial present rupees. Then after that, I can tell it as present worth money or the present worth value of the money. Because value of the money today may be different, tomorrow it may be less, or tomorrow depending upon the inflation, discount rates, or the percentage rate of the loan. So all depending upon that, this present worth factor also depends. So keeping that in mind, we are going to find out with the discount, with inflation, or with change of interest rate of the loan, everything, how the present worth value can be found out. So that will help us to find for a n number of years what is the value of the money today. So in this one example, they have explained here at the top, at a discount rate of 15%, a sum of 100 next year is worth of. So to find out that with a discount of for 100 rupees, if you take 15% discount, what is the value? It is around 86.95 or 85 rupees yearly. Okay. Or we can say, okay, or we can say what we can say, this rupees 86.95 invested today may get us 15%, or it can grow by 15%, and we can get 100 rupees next year. So both ways are possible. Whether we want to spend money with a discount, or keep the money as bond or FD or some between understanding, or pay as a loan and get the EMI from the customer as 15%, then you can build this money. Then later, this 100 rupees you can spend on your own spendings. So this is the advantage of money, what you can savings or spendings, or increasing the value of the money or decreasing the value of money. This all depends on this calculations of discount. Okay, so similarly now you can see which present worth factor. Okay, so value of the above sum is present value. This is termed as present worth factor, and it is obtained simply by dividing the equation 25.1 by the compound interest term 1 plus t rate. Whatever they have done, it is not important. Important is the final equation what we are going to use to find out the present worth factor and the present worth value of the money. That is required for us. Now here you can see with and without discounting. If you see, this is the change in the present worth factor. Okay, so that values we are either with discounting or without discounting we are checking. So with discounting, if it is there, the present worth factor will be little bit higher side. Okay, and without discounting, if you see, the present worth factor will be at the zero line only. Later it will go on with this. Means initially the benefits will be given to the customer. If the discount is given from the supplier side, it is benefit to customer. Or customer, if he give loan or some money lending business, if he do, initially he will be in benefit. So any one of the way he can choose, and according to that he has to move. This is all about just finding the value of the money at the present after knowing each year the value of the money. So finally, the equation you can note down to find out the present worth factor, okay, with discounting. That is 1 minus into bracket 1 plus inflation rate, I is inflation rate, divided by 1 plus D is discounting rate, raised to n. N is the number of years. The whole bracket into 1 by D minus I. So D is the discounting rate, I is the inflation. Inflation is price hike percentage every year. That is I. So many people will think buying the devices or the goods at present is more worth, so that in the coming years the rate may increase. That is inflation. In other case, buying the old goods at a discounted rate is also advantageous, so that whatever the profit we get for a given discount, that is also benefited. So that we are going to compare with discounting and without discounting. And whenever this discount rate is equal to inflation rate in such condition, so then that equation can be written as, just you put this d equal to I. So that will become, after opening the bracket, n into bracket 1 plus I raised to n minus 1 divided by 1 plus I raised to n. If discounting rate and the inflation rate is same, or even though you can use the same equation, 25.4 equation, same equation you can use, put d and I same values. Then also you'll get the answer same, or else you can go by this equation, n divided by 1 plus I. Both are same. So today we'll take one example and we can stop the class, so that later all the students can do the quiz. So here you can see the present worth of capital and maintenance costs. So in this, what they are doing is present worth of the amount of the money they are finding, and also the with maintenance cost. So at the present of anticipated savings must be compared with the present value of the cost of payments for capital and maintenance charges related to the investments. So for this, they are taking one ratio of the rate, so that investment or the borrowed money or the loan money, whatever is taken, is to be repaid in equal number of installments with interest charge at a rate of R%. So this R% is considered, and to pay the money. Okay. So the loan interest rate R is different from the discount rate, because discount rate is different. It is given one time, not continuously. But interest rate is continuous. Every year, this interest rate should be counted, and you have to pay the interest rates. So now we can use the present worth factor equation to find the amount of equal installments of loan. Say for example, you are paying one loan or you are giving a loan, then how to find out the equal installments of payments, provided this loan interest rate and the inflation rate. Inflation rate for the loan will be zero, because in between you cannot change or increase the rate of interest. At the initial step only you have to explain all the conditions. With the fixed inflation rate, or the inflation rate will be zero, with fixed rate of return or the interest rate. So if that is given, then if you know the rate of interest, then what you can do is you can use this equation, 1 minus 1 divided by 1 plus R raised to n, bracket close, into 1 by R. So this R is the interest rate. Interest rate of equal installment rate, and by this one can find out what is the present worth factor. So on that factor, every year the installment amount can be found out. We will see this problem and we'll stop the class. Proposed insulation system for a house. Proposed insulation system for a house to be heated. Okay, for heating of the home, they are going for insulation. The entire home is insulated. Is expected to save the fuel costs of rupees 2000 in first year. So fuel cost means they are indirectly telling the electricity saving. Or electricity is produced from the conventional system like coal or some diesel plants. So in that case, we can directly say that it is a fuel cost savings. Okay, it is expected to save the fuel cost of rupees 2000 in first year. The first year it is saving 2000 rupees. Fuel prices are expected to increase by 20% per year. So this will become inflation rate. So fuel prices are increasing by 20% per year. And best alternative investment will yield, if you compare with the alternate investment, will yield you 10% per year. So 10% per year discount you can get if you invest some of the money or same money in the alternate what you can say investment. So that is 10% discount if you want. Find the total savings from this purpose proposed system expressed in the current value. So current value, anytime if they say tell, it is nothing but the present value factor or the present worth factor. Okay, and take the life of the system 15 years. So they have given inflation rate 20%, discount rate in the other investment or the profit from the system itself maybe 10%, and life cycle is 15 years. So taking this equation, present work factor is given by 1 minus into bracket 1 plus I by 1 plus D whole raised to n bracket close into 1 by D minus I. I can substitute all the values here. 1 minus 1 plus I. I is 20%, so it is 0.2. 10% discount 0.1 raised to 15 years into 1 divided by discounting is 0.1, inflation is 0.2. I can take that difference. Now, whatever the factor you get, say for example 28.5, 28.9 is the present work factor. That factor should be multiplied with the savings or the amount. Means after 15 years, how much you are saving, that I am telling today as per present values of inflation and the discount. I hope you are understanding. That present value of inflation and the discounting rate after 15 years, whatever the savings can be done, that is multiplied, that factor is multiplied with the present cost. Means after 15 years, with per year 2000 savings, okay, if you find out with inflation and discounting rate, I can save after 15 years at present, okay, present value of rupees, I can save 57,800 rupees. So spending on this insulation purpose or the insulation of the home, if it is below 57,800, then it is benefit only. Like that we can think. Is that clear? Or if he is asking for 10,000 of insulation of entire home, then anyhow for 15 years, if you calculate, I am going to save this much of energy, or even not 57,800. Okay, maybe quality of work may be less. Even if the 50,000 above, if I am saving, then it is better option to go for the insulation of entire home. Okay. So similar cases we'll take in the next class, and we'll discuss one more factor, that is the I think payback period. So that is also one of the factors there. With this payback period, we'll discuss the remaining concepts. So all of are here. So go to the Google Classroom. Here there's a link in the classwork. In the classwork, you have quiz 1. Quiz 1, you can directly click on this link, or the quiz 1 you can click and do the quiz before 3:30.
So now the time starts.
Yes?
So now the time starts.
Yeah, 3:15. It may open now. You can click the link.
Okay, sir. Okay, sir. Thank you.
Thank you, sir.
Okay, I will close the class. Just inform all the students of solar subject to give the quiz.
Okay, sir.
Because only 15 or 14 students are here. Another 15 students are not attending class. So just inform them to give the quiz.
Okay, sir. Thank you.
Yes.